Alkylation reaction. So most of these reaction names are suggestive of what's happening. Alkylation should make us think, oh, an alkyl group is being put onto something. This is where an alkyl group is transferred from one molecule to another. And this is one of several ways of preparing amines. The alkylating agent is going to be an alkyl halide. So if we take ammonia and react it with an alkyl halide, we'll get a primary amine. So the ammonia is NH3. This alkyl group is going to substitute for one of the hydrogens. A primary amine with an alkyl halide, you'll get a secondary amine. Secondary amine with alkyl halide, you'll get a tertiary amine. And tertiary amine would give you a quaternary ammonium salt. So it's just the alkyl halide will substitute the alkyl group in for one of the hydrogens on that nitrogen. Under basic conditions, this is a two-step process. The first process is that an amine salt is produced. So here you have the ammonia and the alkyl halide, and they're going to form an amine salt. Because this is in a basic condition, this is like part C that we just did, the reaction of an alkyl ammonium salt with a base. The acidic hydrogen on this ammonium salt will be given to the hydroxide to form water, and then we'll get our free amine. So the example here is the formation of ethylamine. So here we have ammonia and ethyl bromide. The ethyl group of the ethyl bromide gets transferred to the ammonia. Because it's in a basic solution, then we get the free amine, the ethylamine. So we looked previously at the primary, secondary, tertiary, etc. sequentially. If you don't do anything, what's to prevent this primary amine from reacting again to form the secondary amine? There really isn't anything to prevent it. So if you want to form a primary amine or a secondary amine, you're going to have to do something to pull that product out or stop the reaction or something. Otherwise, it'll just continue to react. Let's look at this example. Here we've got a primary amine. We react this with methyl bromide. This methyl group is going to substitute for one of these hydrogens. And now we've got ethyl methylamine, a secondary amine. If this is in that same reaction mixture, that secondary amine is going to undergo alkylation again, and you're going to end up with a tertiary amine. If you have strong base present, you can get tertiary amines to react and produce quaternary ammonium salts. And that's an ammonium salt where all four groups are hydrocarbon groups. The ones we looked at before, all the ammonium salts, had hydrogen, an acidic hydrogen here. But here, all four groups are alkyl groups, hydrocarbon groups. Quaternary ammonium salts are very important in biochemical systems, and two examples are choline and acetylcholine, and these are involved in neurotransmission, and so they're pretty important. Now, the quaternary ammonium salt is not going to convert back to an amine by the addition of strong base, because there's no hydrogen on that nitrogen. If we look here, here's ammonium, and if you react that with strong base, there's an acidic hydrogen here that can react as an acid. This compound here has no acidic hydrogen. It cannot act as an acid, and so it will not react with the base. We name the quaternary ammonium salts in the same way that the amine salts are named.